So I haven't posted a video in a while, so I thought I'd take a look at this little device I bought from TEMU. It's a USB cable tester, and I was going to make one because they're fairly simple, but this was so cheap, didn't see the point in making one myself. So let's have a look at it. It comes in this quite nifty little box with a nicely padded case, so that'd be good. Turn it the right way up. It's got a power in, and that's a USB-C power in. Standard USB type A connector, and then you can test for type C, Lightning cables, which are the Apple ones, another type C there, and micro. So these are for one end of the cable, and these points are for the other. So let's give it a go and see how we get on. So I'm powering off a USB-C, and it's clearly marked power in. So let's try some cables. And what the device does, it checks for power and ground, and then data lines, and then for USB type C, it tests for CC, which I'm not sure what that means, but I'll look it up and put it in the text of the video. Okay, so this one is a USB-C to Lightning. So if I shove that in USB-C there, pop it in the Lightning connector there. Oh, that's interesting. So what we've got now is clear ground, poor VCC, and good data lines. So let's try turning that cable over, because they're dual-sided, these Lightning connectors. Again, there's power on that VCC, so let's turn the USB-C over. Whoops. And again, not very good. So let's try it with a different cable. So this is a USB-A to micro connector, so let's put that one in. So here's where you get a bit of a problem. With these short cables, it's a bit of a stretch, and you can see there's nothing wrong with the board, but there does appear to be something amiss with that VCC line. Now that might be related to this Type C connector as a test point, because we've or it could be connected to the Lightning one. So let's have a look what else we can find. So this is a cheap Lightning cable. Let's plug that in. And we've got a data issue on that cable, which is worth knowing about. Yeah, so there's a line down on that cable, so that proves that cable's defective, which is quite useful. Let's put that out of the way, get rid of it. I've got a USB-C to A connector. Put it in the right way around, that would help, I think. So, USB-C into the test point, and we've got all 4 power connectors. Excellent. So, how much did I pay for this thing? About £3.50, I think. What's that, $4? $4.50. So, was it worth it? I think so, yes. Highlighted a problem with one cable. Not that I expected a lot from it. So how do we deal with these short cables then? Well, if you think about it, every time you test one of these, primarily if you've got it, particularly with the USB-A connectors, you know, if you use this one 10 times, this one 10 times, and this one 10 times, you're going to use this one 30 times. So it's probably better if we go to some sort of adapter that we don't put the wear onto this, but we put the wear somewhere else. And I have somewhere, he said, a USB extension. So this is my USB extension lead. You see socket on one end, plug on the other. Let's open that up a bit. So what we can do, is plug that in there, and then what we're going to do is transfer any wear and tear onto this connector. So let's try that with our short cable again. So here's our short cable. Let's pop it in here. Pop it in and test it. So as we expected, because it's a little short cable, and this was actually for a little cheap USB power bank, all we're really interested in is the power lines. So it also relies on your extension having a good set of data lines in it in order to do the test. So we can check that. And this is a type C. So yeah, so it's proving that all the lines are good on this one. Got doubts about that USB-C to lightning connection that we were looking at earlier. It suggests it's probably on the USB-C line because that's a different cable. So what we can do, I have a very handy little adapter here that takes a USB-C to USB-A. Pop that in there, pop that in there, and then test that in the lightning. So it's probably the lightning connector here that's faulty on this board. Interesting. So once more, so I've got a USB-C to USB-C. Let's want my power line again. Alright, USB-C to USB-C, and that's showing all 5 lines is good. So that suggests that doubly suggests that the lightning connector is a little bit iffy. We find another lightning cable. Again, this is a cheap one. Oh, there we go, and that's working. So that suggests probably, as the type of cable test is supposed to do, the cables are a bit dicky. That's interesting. Let's try again with that. With this one. So I'm using my adapter to USB-C to lightning, and again it's showing it's dicky. Let's put this USB-C, and it's again suggesting it's dicky. So it's showing there's problems with the cables, which is exactly what it's meant to do. One of the other useful features of this board is that it gives you access to all the pins via these little pads, and rather handily the pads are labelled. So what I tend to do is I've got a dodgy USB cable, so I don't use it again, I cut it in half. But the fault must lie somewhere, it's either at one end, the other at some point in between, which is a bit obvious really. But if you cut it in half, you might be able to use that end on a project somewhere that might require that kind of connector. So if you end up with something that looks a bit like this, then arguably it's not going to be much use for anything. But if you've got a slightly longer one, like this one, you can check the integrity of the cable by plugging into the board and then testing the continuity of the cable, obviously from this end through to the pads on this end. So let's see if we can have a go at that. So I'm going to struggle a little bit. I've got my multimeter out of shot, but you should be hear that on the continuity. And if I stick this on the red wire, keep them out of shot. I apologise, this isn't particularly good. I'm trying to do this with a camera. So the red wire is connected to VCC, or supply, which is what we would expect. I would expect green and white to be the data lines, so let's check those. That's VCC, that's ground, that's D minus, and that's D plus. So that's just the green wire now. So I'm expecting this one to be D minus, which is this point here. Let's see if you can see it a little bit better. There's no shorts to the other wires. So if this final ground wire here is good, we know the integrity of this cable is pretty good. So check for shorts, check for continuity. And of course you can do that with the other connection points as well, because you've got access to them all. So quite handy.